Hello everybody, and welcome to week 4 of Raspberry Pi After School Online. My name is James Dittrich, and I'm an instructor at YSU who is working with Oak Hill Collaborative to teach you about how to use your Raspberry Pi. I'm sure that after last week's lesson, you've done some of your own exploring with your new Raspberry Pi, and that's great. An important part of learning any new skill is experimenting and testing what you've learned. However, while you were experimenting, you might have noticed something different about your computer. Maybe the stuff that you see on your screen looks a little different than what you've seen before. Or maybe the menus look strange. This style is called Raspbian and is unique to the operating system that we're using, called Linux. Here's everything you should have received in the mail this week. The QR code to watch this video, the Parent Guardian Guide, and anything the GUI can do, the command line interface can do better. Last week, we learned about the tools we have outside the computer that help us communicate with it, like our mouse and keyboard. But without all the icons and windows that we can see on the screen, we wouldn't be able to know what the computer is telling us. An operating system not only uses the graphics on the screen to communicate with us, but it also translates what we do with the mouse, keyboard, and any external connection for the computer to understand. There are two major ways that we use our keyboard and mouse to communicate with the computer's operating system. The first is called the desktop environment, or graphical user interface, GUI for short. This interaction you've probably done before. While you were trying out your new Raspberry Pi, you probably clicked on icons, right? That's a GUI. The second way we can communicate is with the command line interface. This is more like what you've seen in action movies when someone is hacking the system, but really it's more simple than it seems. The command line interface replaces pointing and clicking with typed commands and phrases to explore the operating system. So the first thing that we want to do is open a terminal window, and for us to open a terminal window, we can use the Pi launch menu, go under Accessories, and choose Terminal. So the first thing that we want to do is find out who we are, where we are, and confirm that. So we can do that by typing the command pwd. And it shows that we are in a folder called /home/pi. Well, why are we there? We can see on the prompt it says pi @Raspberry Pi. So the thing before the @ is our username, sort of like email, and after the @ is our host name, the computer's name that we're on. So pi means I am the user Pi, @ the computer Raspberry Pi. Also, we see there is a colon and a tilde, and let's take a look at what that means. Tilde is a shortcut for the user's home directory, so the currently logged in user's home directory. And how do we get there? Well, there's a command to move around the directory, and we can go somewhere else. So if I do cd/, that means the root directory. The root is the highest possible directory to be in. There is everything is underneath of that. And if we want to go back home, we just do cd tilde, and there we are, back to our home directory. So now that we know where we're at and who we are, we want to see what's in this directory. How do we find that out? Is with the list command. So list is just simply ls. And if we hit enter, we can see there's a whole bunch of subdirectories underneath this one. Desktop, which is the desktop that we're looking at behind us. Documents, downloads, music, pictures, public, Python games, templates, and videos. So if you're using a web browser and you download something from the web browser, usually it defaults to going in the Downloads folder. Music, pictures, videos, those sorts of media files should go in those places just to keep you organized. Documents, things like text files and Office documents should go in the Documents folder. If we want to go to the desktop, we just cd
And we can start by typing in capital D, E, S, and then we can hit Tab. And what that does is it completes the command for us because it matches those letters. And there's only one subfolder that matches. And here we are. And if we print the working directory, we can see that we're in /home/pi/desktop. If we list the contents, there aren't any. And you might be thinking, what about the trash? Well, the trash is just a system icon that shows us where the stuff that gets deleted goes. So that doesn't count. Next, we're going to go back to our home directory, cd tilde, and then we're going to list the contents of that directory again, but we're going to use -a afterwards, so ls space -a. And now we get to see a lot of these files that are prefaced with a dot, right? So .bash history, .bash logout, .bash rc. And what are these files? Well, they're hidden, right? So showing all the hidden files is what the A command flag shows, all the files in the directory, including the hidden ones. We don't have to worry about those files just quite yet. One thing to know is there is a command history, and if you use the up and down arrow, you can go back through all the commands that we issued. That can help speed you along and makes the command line a lot faster than just typing everything in. We can just choose one of the commands that we ran and just run it again by hitting enter. So up arrow scrolls back through the history, and then just press enter like you're entering a command by typing. Next, I want to talk a little bit about these two special directories. These are special shortcuts for the system, dot and dot dot. So one thing we can do is we can cd to dot, so cd space dot and hit enter, and you'll notice it didn't take us anywhere. And that's because dot is the shortcut for the current directory. The next thing we'll want to do is we will change directory to dot dot and then hit enter. And now you can see on the prompt it says /home. If we print working directory, that's in fact where we're at. So for us to get back to where we needed to go, we can either do cd pi or cd tilde. It takes us back to our home directory. So let's take a look and see what's in the directory above. And we see that we're the only user on the machine right now. Anytime you want to go one directory above where you're at, you can use that same command, cd dot dot, and it moves you one directory. And so now in the root directory, we can see that home is just one of many of these directories. And there's a lot of these that contain system files and things that we shouldn't mess around with, but that's where they're at. Obviously, boot is where the files needed to boot the computer are, right? And there's a lot of these different things that we'll talk about in just a little bit, but for now, let's stay out of there and we'll go back to our home directory. If we want to look at certain things about the files that are in the directory, we can use the L flag. And what L does is it tells us certain things like the file permissions. D means that this file is a directory. RWX means read, write, and execute. So the first three permissions, RWX, are for us. We own this folder and we have the ability to read, to write to it, and also to execute the commands that might live inside of there. If there's any programs to run, like in Windows, it would be like an exe file executable.
We can run it from in there because we have permissions to do that. The second group of RWX, we notice there's a hyphen there. That means that this set of permissions does not have write. So this is called a group permission, and our group is also pi. So the first name right here is the user, and this is the group.
We can run it from in there because we have permissions to do that. The second group of RWX, we notice that there's a hyphen there. That means that this set of permissions does not have write. So this is called the group permissions, and our group is also pi. So the first name right here is the user, and this is the group. And then the last bit right here, R-X, means that anybody on the system can read or execute the things that are in there, right? So permissions are important, especially when there's multiple users on the same machine. If you want to keep things private, then you don't grant read permission, because if you did, anyone can just read what's in there. So up until this point, we've been navigating the file system by using the cd command, and we could always get back to where we were going and confirm where we are with the print working directory command. Now, let's say we want to create our own folders and create our own files. So what we're going to do is we're going to go to the desktop. And remember, you can always start typing the word and then hit tab and it will complete that for you. And next, we're going to create a directory. So the command to create a directory is mkdir, make directory, right? And then space, the name of the folder that you want to create. So we will call this notes. Now you'll notice behind here on the screen, there is now a folder called notes. We created it using the command line. Is there anything in it? Well, not yet. It's empty. There's no subfolders. So if we want to go to this folder, we can cd into notes. And if we use the ls command, we can see there's nothing in it, right? Just dot is our current working directory, and dot dot is the parent directory, which is desktop. So if we want to create a file, the easy way to do that is just to use the touch command. So if we touch hello.txt, right? Usually .txt means that this is a text file and it's just plain text inside the file. So if we do this, it doesn't show us that it did anything, but if we look at ls, we can see that there is a file that we can read and write, and everyone else can read. It's owned by us, and it's named hello.txt. You can see that it's created, at the time that I created it, and also it's 0 bytes. That's the size of the file, is 0, because there's nothing in it. Well, how do I know there's nothing in it? Well, we didn't actually put anything in it. So what we'll want to do is we'll want to edit this file. And the system editor on the command line is called nano. So if we use nano, nano, space, and then the name of the file that we want to edit, hello.txt. We see it says GNU Nano 2.7.4. This is the program that we're running. Is GNU made this editor called Nano. And Nano because it's small. And it says file, hello.txt. Now in this window, it's showing us what's in the file, which is nothing right now. It said it read 0 lines because it didn't have anything in it. And we can see at the bottom, there's a bunch of these commands that are listed, right? So it says this caret character, right, which is Shift 6. If you look on your keyboard, if you use the Shift key with the number 6, it gives us that caret character, right? But that's not what it means from that command. So what it means is they want you to hold control. Whenever you see the caret character in Nano, it means hold control and then type the letter that they want you to type. So if I do Control C, it'll give us the current position. It says line 1, column 1, character 0, because there's no characters there. So what we're going to do is we are going to start typing something, right? So hello Raspberry Pi. And I'll end it with a new line by hitting enter. And next we want to write output, which is kind of like saving a file in Windows when you go to save as or save, right? Write out means write the file output. So Control O, that's not a 0, that's an O for out, right? Write out. So Control, hold down Control and then tap O. And it says file name to write hello.txt. And if you wanted to change that, you can use the arrow keys and change that. So if I did hello pi.txt, I could change that. Save file under different name. You sure about this? Yes, we're sure. So Y for yes, and then it says wrote 2 lines. If I exit, that's Control, hold down Control, and then hit X, just like it says down here at the bottom. Control X, exit. And we're back to the shell prompt. So if I look at what's in here now, there is a 0-byte file that we created with the touch command, and now there is a new file called hello.pi.txt.
So we have our 2 files that we created, and if we look at the properties of those files, we can see that we have hello pi that has characters in it. There's 21 bytes. And we have an empty one that we just used the touch command to create. Now if I want to move these things around, let's say if I wanted to move them to the desktop, we use the move command, which is mv space and then the file you want to move. And then the destination of where you want to put it. So mv space, the file name, space, then .. / for the parent directory of desktop. And we can see in the background, here's hello.pi.txt, and if we look in the current directory, it's gone. It actually moved it from one place to the other. So what if we wanted to copy the file instead of just move it? Because all move really is a copy, and then it deletes the old one. Then you use the cp command for copy, and we'll copy. The only thing left in here is hello.txt, and we're going to use the long form, which is called the absolute path of the desktop, which is to say that we can use tilde for a shortcut, /home/pi, and then desktop as the destination. And remember that if you hit tab after you start typing, it will auto-complete it for you, so that speeds things along. So I'm copying hello.txt from the current directory, which is desktop/notes, into desktop. And we can see that it made a copy here, but we can also see that if we look in notes, it's still there. If we wanted to look without clicking, it's much faster. You just type in ls, and we can see that it's still there. So now if we look in the current directory, we just have hello.txt. That looks about right. But what happens when we move something back to where it came from and we don't change the file name? Well, what happens is we'll clobber the file. Clobber being old-timey slang for knocking something out. And what it does is remove the old version in favor of the new one. So just to see how that would work, if we look in desktop and we look at the timestamps, we can see that hello is 33 minutes. Well, the system clock is wrong, but 33 minutes past midnight. If we were to move this file from here back in the notes, we're going to see that there's only one file there because the old one got overwritten. Here's a neat trick. We can always take a peek without having to change directories and list the contents of a subdirectory. Just tell it which one, and you can always use those options. So it shows us those things in there and all the attributes. Now if I wanted to move that again, it says there's no such file or directory because it's not there. So if I copy, see, it reappeared on the screen. But I can always use ls to find out what it did. So note that the timestamp changed, right, because it copied a new fresh copy. If we go back into notes, here's the original, and that's why timestamps are important in the file system. If you compare the timestamps, you can find out if this is the original or if it's the copy. So if we take a look at the version on the desktop, we can see that the timestamp is 38 minutes past midnight. Now the clock is wrong. We can see the current time is 44 minutes past. But let's take a look at the version that's in the notes folder. So we can see the original timestamp is much older than the one that's on the desktop. So this is the original, and the one that's on the desktop is the copy. When we want to move these things around, we want to make sure that we don't overwrite what's there. What we can do is we can use the no clobber. So we know there's a Hello Pi here on the desktop. We know there's one in the notes folder. Let's try no clobber and make sure that it prevents us from doing a bad thing. All right, so what I've done here is that I've said move -n is no clobber, hellopi.txt, and then the current directory, which is desktop/notes/hellopi.txt. So I'm trying to move it from here into notes with the same name. Let's see what happens. And you could see that it didn't tell us that it didn't do anything, but it also didn't copy over. Now if I were to do that from the desktop right now, if you're ever at the bottom of the terminal window and you're kind of mad because you'd like the cursor to be at the top, you can just use clear, and that will move the prompt all the way back to the top of the screen. So we're on the desktop. If I move this interactively without no clobber, it should prompt us. And see, it says move overwrite notes hellopi.txt. We type in Y and hit enter, and that's yes. And see, it moved away. It's no longer on the desktop. And we can also see that our timestamp changed, right? So this is a new copy of the file overwrote the old one because we told it to. That'll keep you out of trouble. The next thing we have to know about is when you copy something, you can actually change the name of the file. So what I can do now is just give it a new name, and you can see we have a new timestamp, and it's an exact copy, both 21 bytes, 21 bytes. How can we tell the inside of that file is the same? Well, we can always go into Nano, like we did before. So hello Raspberry Pi in one, and hello Raspberry Pi in the other, an exact duplicate. Or there's another command that allows us to display the contents of the file directly on the shell. And how do we do it? With a cat, which stands for catalog. Catalog the contents of this file. So we can see there is a blank line at the end of that file, and I put that there intentionally so that we would have a space before the prompt. Any file that's in the file system that's just plain text, you should be able to use this cat command and view. One interesting thing we can do is we can go to the home directory, and we can cat the .bash history file, and you can see there is a command history there of previously used commands. It's not complete because it doesn't write to that file until you close the terminal. So you may be wondering, where are all these other things in the scroll back? They're not actually there until you close the terminal, and then it writes those commands to the history file. Let's go ahead and do that. Control-Alt-T brings up a new terminal window, and you can see we have lots of different commands in here, the entire history of all the stuff we've done, and then some. So what if we don't want to see all of the file, right? Let's look at a large file that lives in the system that tells us about the hardware in the system. So if I cat/proc, right, in the root directory, there's a directory called proc/cpu info. If I do this, it gives us all this technical information, and you can see this is kind of a large file, right? It says ARM v7 processor, right? That is what is on our Raspberry Pi current revision. And it gives us serial numbers and things for the CPU, all kinds of technical details that nobody really needs unless you're interested. Now we have a problem. We have two identical files, and we want to get rid of one. So what we can do is we can use the remove command, and that will delete the file. If we were using the GUI, we would just drag the file to the trash, right? And that would effectively delete it if we emptied the trash. But the rm command deletes it right away. No emptying of trash required. So what we're going to do is we're going to choose rm for the command, space, and then the name of the file. We have to be very careful because there's no going back. And after we do that, it's gone. It's not coming back, and if we go in the trash, it's not there either. So you've got to be sure about this. In this section, I'm going to tell you about how you can update and upgrade your Raspberry Pi operating system, as well as all the software that's on the Raspberry Pi. And we can do this from the command line interface as long as
we're the super user, and we have to have the permissions to do something that drastic. So firstly, I think I should mention that there is a command called apt that lets us look at what needs to be updated on our machine. So we just type in sudo apt update. So it connects to a bunch of archives that have all the information about the software that we're running on our computer, and it checks it against what we're running now. This can take a long time, so be patient, depending on the speed of your internet connection. You might find this takes a really long time over Wi-Fi as opposed to plugging in. So it says 376 packages can be upgraded. Run apt list upgradable to see them. And so this shows us a list of all the software that needs updated. And a lot of these things you might not know by the name what it does, but do know that if it's telling you that it's a good idea to upgrade it, it's probably something you'll want to do. So to update, we want to sudo apt upgrade. Not update, but upgrade. And now it's asking us, do you really want to do this? Do you really want to upgrade all of these things? So we can go ahead and say yes to the prompt. It'll say you need to get 928 megs, in this case, of archives. It can take a while to download all that stuff. So we'll go ahead and say yes. So now that it says done right here, we know it's finished. In any case, try not to be the super user because you can get into a lot of trouble that way. So this is really the only time you should be using it. That being said, you should probably update your machine frequently, on a weekly basis even.
Congratulations! You've now got all the tools you need to write a complete short story using just the command line interface. The possibilities are endless. Working together, you and your computer will be able to solve problems, play games like Minecraft with your friends, or even program your own games. We'll talk more about that next time. Until then, this is James Dittrich with Oak Hill Collaborative, signing off.